Swayam Prabha. Digital India. Educated India.
So, friends, on a course of production and operations management, we are discussing production planning and control, and in the last session we talked about scheduling and sequencing, the importance of scheduling and sequencing, why this is important for job shop production system, batch production systems, and what are the various performance measures. And in that we took one illustration of Johnson's rule, which was meant for n jobs and 2 machines. We took one case, that is n jobs and 2 machines, and we applied the Johnson's rule, and we found that we are able to reduce the total make spend time by around 17%. So, that is the improvement in the efficiency by applying the Johnson. The steps in the Johnson's rule, just to recollect that: list all jobs and time for each machine and work center, that we can have this kind of information available with us. Choose the job with the shortest activity time. If that time is for the first machine, schedule the job as early as possible. If it is for the second machine, schedule the job as late as possible. Once a job is scheduled, it is eliminated from the list, and we have to repeat step 2 and 3 working towards the center of the sequence. After doing that, now let us see another illustration where we are having n jobs and 3 machines. Now, we are considering 3 machines rather than 2 machines, we are considering 3 machines, and we are having n jobs. Again, take a simple case where we are having the 5 jobs, A to E, we are having 5 jobs, and this is the data we are having, information about that we are having. Like each job is moving from machine 1 to machine 2 and then going to machine 3. It means that there is no crisscross, it is that every job is first going to machine 1, then it goes to machine 2, and then it moves to machine 3. So, jobs are not going from 3 to 2 or to 1 or in some other manner. Each job is following a very disciplined rule of machine 1, then 2 and then 3. This is also happening like in metal cutting case, where you are manufacturing gears and other things, or rotors in case of electric motors. Metal cutting case, the first machine is, let us say, lathe. Invariably the first operation is carried out on a lathe, then you are doing on a milling, and then you are doing the operation on a maybe some kind of a grinding or shaper or some other operation. So, all the jobs, if you are manufacturing certain shafts of different sizes, each will first go to lathe, then milling, and then going to the grinding operation. So, like this process sequence is generally let us see the modified Johnson's rule. What is modified Johnson's rule and how to apply? To apply the modified Johnson's rule, the one of the 2 conditions must be met. Condition is the minimum processing time on machine A should be greater than the maximum processing time on machine B, or the minimum processing time on machine C should be greater than that of machine B. Let us see in our case whether this condition is satisfied or not. If it is satisfied, then only we can apply the modified Johnson's rule. So, the condition is the minimum processing time on machine 1. The minimum processing time on machine 1 is 10. It should be greater than or equal to the maximum processing time on machine 2. The maximum processing time on machine 2 is 9. So, this condition is met. So, this condition is met. We can say that the processing time, minimum processing time on machine 1 is greater than this. Let us see for this whether this condition is met or not. The minimum processing time on machine 3 is 2. Now, this is not greater than this, but our requirement is out of the 2 only one need to be, at least one should be met. So, in our case this first condition is met, second is not met, but even then we can apply the modified Johnson's rule, because it requires that out of the 2 any one should be met or both should be met. So, once we check that yes, we can apply the modified Johnson's rule, now we convert the case of n jobs 3 machines into n jobs 2 machines. We will, because we have the algorithm available only for 2 machines case. So, we will convert the given situation into a 2 machine case. So, we can say for example sake, this is machine 1 2 and this is machine 2 3. We have given another name to combined machine 2 3. Here we will write the time of machine 1 plus machine 2. We will write the time of machine 1 plus machine 2. That is 10 plus 7 17, 18 plus 9 27, 16 plus 8 24, 15 plus 3 18, 12 plus 2 14. Similarly, here 7 plus 18 25, 9 plus 6 15, 8 plus 15 23, 3 plus 2 5 and 2 plus 20 22. Once we have done this, now it is a case of n jobs and 2 machines, and we can very easily apply the Johnson's rule. As we know, what is required in Johnson's rule? We have to make 5 jobs are there. So, we have to make 5 slots here 1 2 3 4 5. Again, now follow the steps, find out the minimum time in this. The minimum time is 5 belonging to job D and under second machine. So, to be assigned as late as possible, to be assigned as late as possible. Just recollect the rules. Choose the job with the shortest activity time. If that time is in the first machine, schedule it as early as possible. If it is in the second machine, schedule it as late as possible. So, it is in the second machine, schedule it as late as possible. D is eliminated from the list. The next minimum is 14. The next minimum is 14. So, 14 is in the machine 1. So, E to be scheduled as early as possible. Okay. Now, E is also done. Once the E is done, now next find out the minimum, that is B. So, B is to be scheduled as late as possible. Once that is done, then the next minimum is 17. A to be scheduled as early as possible, because it is under machine 1. Once that is done, now we are moving towards the center of this. The remaining job which is left is C, like this. So, this is my optimal sequence. I should possess these jobs in the sequence of E, A, C, B and D. So, the very simple rule, Johnson's rule, modified Johnson's rule, convert the case of 3 machines to 2 machines, provided one of the condition is met, whether condition 1 or 2, out of the 2 at least one should be met. Then we can convert and we can apply the modified Johnson's rule. So, this is what I have got, E, A, C, B, D. E, A, C, B, D, this is the sequence we are able to achieve. So, very simple rule. So, we can apply very easily. Now, let us see, let us try to find out the make span time. With this, let us try to find out the make span time. Let us try to find out the make span time. First step is convert the given into the desired information. Now, we have to make the sequence E, A, C, B, D rather than A, B, C, D. So, this is the jobs to be processed in the as per the optimal sequence. This is the optimal sequence. Okay. So, we arrange the jobs into the sequence which we have identified using the modified Johnson's rule. Now, for this let us try to find out the total make span time. Let us try to find out the total make span time. So, let us processing times we can copy here 12, 10, 16, 18, 15 and then similarly for machine 2 we have 2, 7, 8, 9, 3. For machine 3, we are having 20, 18, 15, 16 and 2. Okay. So, as we are doing earlier, we can start at time 0, complete at 12, start at 12, complete at 14, start at 14 and do it at 34. Okay. Here we can start at 12, job A we can start at 12 on machine 1 and complete at 22. We can start 14 and 22, we can start at 22 and finish at 29, and we can start at 29 and 34, we can start at 34 and finish at 52. Similarly, here I can start my third job at 22, 16 is the time. So, 38 I have to finish, and then I can start at 38 and complete at 46, start at 46 and 52. 52 I have to take the higher. Job is available at 52, but machine is available at 52. Job is available at 46, machine is available at 52. I can start only when both are available. 52 plus 15, 67. Again we can come back here, 38 plus 18, 46, 56. We can do it here, 56 plus 9, 65. 65 plus I can start at 67 only. I can start at 65, I can start at 67 plus 16, 83. So, same way here I can come here 56 plus 5, 15, 61, 71. I can start at 71, 74 and then I can start at 83 to 85. So, this is how the total make spend time is 85 minutes, 85 units of time. So, all the 5 jobs can be accomplished in 85 units of time by following the optimal sequence. We can also work out if we follow the sequence A, B, C, D, E, what will be the make spend time as we did for the 2 machine case. Now, we can develop the Gantt chart for this. The same information which I have written with the hand, I have copied here. And we can draw the Gantt chart for 3 machines. So, okay, we are having time 85 available up to this. So, we are able to draw the Gantt chart. So, very easy, just for the practice purpose, let us do it for machine 1. Machine 1 starting at 0 and up to 12, it is doing E. It is doing E up to 12, and then from 12 to 22, it is doing A. Then from 22 to 38, we are considering this column. So, 22 to 38, we are doing C. 38 to 56, we are doing B, and then 56 to 71, we are doing D. Okay. So, that is how we can draw the Gantt chart for machine 1. Okay. We can shade it also if we required, just for to make it to express that this is the time required. Okay. So, this is how the 5 jobs in the sequence E, A, C, B and D are carried out on machine 1. Let us see on machine 2. Obviously, on machine 2, first 12 minutes it is ideal, there is no job for it, it is ideal, nothing, no, it will start at, we have to find out, we will take this particular column. So, first job 12 plus 2, 14. So, job E is finishing at 14, starting at 12 and then 14 to 29. So, this is our 20, 30. So, somewhere here we can mark it as 29 and we can write job A. then 46, this is your 40, this is 45. So, somewhere here I can mention 46 and the job is C, and then 65, 65 is somewhere here. I can say that this is job B, and then 65 to 74 somewhere here, that is my job D. Okay. So, this is how this is to be done. Okay. So, this is how the job machine 2 is utilized for various jobs, and we are finding that there is no ideal time on machine 2. There is a no, sorry, there is a mistake. So, after doing the machine 1, now we are doing the Gantt chart for machine 2. So, for machine 2, up to the 12 units of time, the machine is ideal. There is no work on this, because job E is available only at point 12, and 12 to 14 we have to plan the job E. Okay. Now, the next A is coming at 22. So, this is 20, this is 22. Again the machine 2 is ideal for this period of time, and it will be going up to 29 only. So, that is A. Okay. The next job will come at 38. Again the machine 2 is ideal during this period, and going up to 46, going up to 38 to 46, that is job C. And then again it has to wait till 56. It has to wait till 56, again 56 to 65 it is processed for job B, again for 65 to 71 it has to wait, and then 71 to 74 is the job D. So, this is how the machine utilization of 2 is very less. In between there are ideal time. Total workload also is very less on machine 2. Okay. Now, coming to the machine 3, let us pick the green color for this. Coming to the machine 3, so these are the processing times, this is the finishing time. So, we will take this particular matrix for the purpose of machine. So, it will start at 14. So, it will start at 14. Prior to that, the machine is not having any task. The machine is not having any task. The machine is not having any task. Then it will run up to 34. It will run up to 34. So, this is my 30. So, this is somewhere I can, this is 38. So, I can say this is my 34. So, first job is taking 20 units of time, and it is going up to 34, that is job E. Okay. After doing that, then 34 to 52, 34 to 52 is my job A. Then 52 to 67, this is 67, 67 somewhere here. This is job number C, and then 67 to 83, 67 to 80, 83 somewhere here, job number B, and then 83 to 85, job number D. So, this is how the plan for machine 3 is. Machine 3 up to 14 it is ideal, then 14 to 34 it is A, then 34 to 52 it is 14 to 34 it is E, 34 to 52 it is A, 52 to 67 it is C, then 67 to 83 it is B, and then 83 to 85 it is D. So, this is how we are able to schedule these jobs. Okay. By getting the optimal sequence, we are able to complete all the 5 jobs in 85 time units. In 85 time units, we are able to do that. So, this is how we can apply the Gantt chart, and we can do the modified Johnson's rule. We can do the modified Johnson's rule. So, in Johnson's rule, for whether it is a case of 2 machines or it is a case of 3 machines, one of the important assumption was there is no due date, there is no due date of the jobs, and number 2, each job is going to machine 1 and then machine 2, and in case of 3 machine case, it is going to machine 1, then 2 and then 3. Okay. So, these are the 2 cases of n jobs and 2 machine, n jobs and 3 machines. Now, we take the one more case, that is applying the Jackson's rule. We will apply the Jackson's rule. Here we are having n jobs and 2 machines. There is no due date, there is no due date also, but job can take any route. It can go for machine 1 to machine 2. There may be certain jobs which are going from machine 2 to machine 1 also. So, we are having different types of jobs. Some are going to machine 1 to machine 2, some are going from machine 2 to machine 1, and there are others which require only machine 1, and there are few which are require only machine 2. So, in that way we are able to, we are having 4 groups of machine, we are having 4 categories of jobs, not machines. We are having 4 categories of jobs. Category 1, class 1, group 1 is which are going from machine 1 to 2, another is which is going from 2 to 1, another is which is going from machine 1, another is which is going to machine 2. So, like this there are 4 groups we can say we are having. So, we are having 4 categories of jobs available with us. There are certain jobs, we can divide them into groups. Group 1 needs only machine 1, needs only machine 1. So, which are the jobs which require only machine 1? There is a job B which require only machine 1. There is another job F which requires only machine 1. So, there are 2 jobs which require only machine 1. Okay. Then we can have group 2, then we are having group 2 which require machine 1 followed by machine 2. So, we are having machine 1 and then 2. So, job A in this category, and then we are having 1 and 2, again we are having I, job I 1 and 2, and there is another job K which is having the sequence machine 1 and then machine 2. Then let us see the group 3. Then see the group 3 which needs only machine 2, needs only machine 2. Which are the machines jobs which require only 2? E is 1, E is one job which require only machine 2. Then there is a G which requires only this. Then there is 2 jobs are required which require only machine group 3 only machine 2. Let us take the 4th group. 4th group we can take group 4 where first machine 2 and then machine 1. Okay. So, which are the jobs? Job D is 1, job D is 1 which requires 2, then 1, then job H is there which require first machine 2 and then 1, then there is a J which requires this. So, we can have a count how many jobs we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that means we have missed certain jobs. We have missed certain jobs in this category. So, we have considered A, B, C we have not considered, C is 1 and 2, C is also there 1 and 2. So, we should have written C also here. So, C is also 1 and 2 and A, B, C, D, E, F, G, H, I, J, K, L also we have missed only 2. So, L can also be written here. Now, we are having all 12 jobs, 2 jobs are in group 1, 4 jobs are in group 2, 3 jobs are in group 3 and 3 jobs are in group 4. So, this is how we are first step is to classify the jobs into various groups. So, now in this information which is given to us, if we say that job A has a operation 1, then operation 2 and the time for operation 1 is 6 units of time and time for operation 2 is 3 units of time. So, same way all information is given to us. So, this is the processing timing and this is the machine numbers requirement. This is the machine number requirement for operation 1 and 2 and this is the processing time requirement for operation 1 and operation 2. So, we are able to get the list that group 1 I am having 2 jobs, group 2 I am having 4 jobs, group 3 I am having 3 jobs and group 4 I am having 4 jobs. Okay. Now, next step in this Jackson's rule is we have to find the optimal sequence for group 2. We have to find the optimal sequence of group 2, optimal sequence of group 2 using Johnson's rule. Using Johnson's rule. So, we will list the 4 activities, 4 jobs, that is A, C, I and K. We will write down their processing time from the previous slide. A is having the processing time of 6 and 3. So, we have copied it there 6 and 3. Similarly, C has 2 and 5, I has 6 and 2 and K is having 1 and 7. Now, we can apply the Johnson's rule, 4 jobs are there, divide this, make a box of 4 jobs and then find out the job which is having the minimum processing time. In the whole matrix the minimum time is 1 and this is under machine 1. So, K to be assigned as early as possible. Next minimum is 2 here in the first column, C to be assigned as early as possible, another is 2 here, I to be assigned as late as possible and then A. So, that is my optimal sequence for group 2 jobs. Now, same way let us find out the optimal sequence for group D category of jobs, group 4 category of jobs. There we are having 3 jobs available D, J and H. So, we have taken the processing time from our original slide and then we can find out what is the minimum time here 1, that is under machine first column. So, process it at as early as possible, that is we are doing it here and then next minimum is 3. So, doing it as late as possible, the remaining is D. So, my optimal sequence is J, D and H. So, having done that, now we have to assemble the 4 groups together in the optimal sequence on machine 1 as well as on machine 2. Now, this is the total picture I have again collected together. So, we divided, this was our original information, we were having 12 jobs available with us and these 12 jobs are of 4 different types, which we have divided them into 4 groups. group 1 only machine 1, group 2 machine 1 followed by machine 2, group 3 only machine 2, and group 4 machine 2 followed by machine 1. And then we have determined the optimal sequence also for these two groups, for group 2 and group 4. Now, give your 200% how to assemble them together to determine the optimal sequence for machine 1. Machine 1 has to possess three groups of jobs. One is group 1, then group 2 and then group 4. So, in this first I will assign group 2 jobs which are to be done at machine 1. They do not have any predecessor requirement. So, they can straightway start on machine 1 and in the optimal sequence A C I K. Optimal sequence is K C A I. So, they have been arranged K C A I. So, this is my group 2 jobs in the optimal sequence. Then I will assign the group 1 jobs which require only machine 1. They are also freely available, independent available, and so I will assign B and F here. B and F are assigned here. By the time these jobs are over, I am expecting that machine 2 has finished the group 4 and now these jobs are available at machine 1. So, then I will put the group 4 here, J, D and H in the sequence J, D and H. So, this is how I got the optimal sequence on this is how I get the optimal sequence on machine 1. On machine 1 my optimal sequence is K C A I, that is jobs of group 2 in the optimal sequence, followed by jobs which require only machine 1. So, then followed by jobs which require only machine 1 and then followed by jobs which are coming from machine 2. Okay. Same way on the machine 2, first we will put group 4. Group 4, those jobs which are to be processed first on machine 2, then on machine 1. Why we are doing it? So that I can make them available for machine 1. I am taking them first, so that I can make them available to machine 1 as early as possible. So, we are taking the optimal sequence of J, D, H here. We are taking the optimal sequence of J, D, H here, group 4. Then we are taking group 3, which is independent, anytime they can be processed on machine 2. So, we are taking E, G and L. We are taking E, G and L as group 3 and then we are taking group 2. By this time they have been processed at machine 1 and now we can do it on a machine 2, K C A I. So, this is how we are able to determine the optimal sequence for these 12 jobs which are to be processed on 2 machines, and these jobs are of 4 different categories as compared to Johnson's rule, where all the jobs are of same category, first on machine 1, then on machine 2. So, this is all the components are assembled together in one single slide. This was our original data information about the 12 jobs and 2 operations are there. Some are on machine 1, some are on machine 2. So, and then we divided them into 4 groups. So, this is our step number 1, we are having data about that. Then this is step number 2, divide them into 4 different groups, and then for group 2 do the, this is step 3, find out the optimal sequence applying the Johnson's rule. Then step number 4, find out the optimal sequence for group 4 activities, and then as a step 5, assemble them together and determine the optimal sequence of all the jobs on machine 1 and on machine 2. We can draw the Gantt chart also for this, for machine 1 and machine 2. Our sequence is here, our timings are here. So, we can very easily draw the Gantt chart also for this. So, after doing this identifying the sequence on machine 1 and machine 2, we can draw the Gantt chart also as we did for the Johnson's rule. So, we can plot the Gantt chart also. but slightly more care is required in plotting the Gantt chart here. So, our sequence on machine 1 is K, C, A, I, and then B and F further we can divide, and then there are 3 groups of jobs. So, let us start with K. K time is 1 unit. So, let us draw 1 unit and write K here. After this we are having C. C require 2 units. So, write C here and 2 units 1, 3, and then after that we are having A. A requires 6 units. So, 3 plus 6 9, that is job A, and then we are having I. I requires 6, 9 plus 6 15. So, that is I. So, this is how I can plot the Gantt chart for first 4 activities of group 2. Then I have to plot B, that is job B, which has a time of 3. So, 15 plus 3 18, and write B also. After that F is having 1. So, 18 and write one more, that is F. After that I have to stop here, I will wait for the J. So, for that I will start with the machine 2. I will start with the machine 2. Machine 2 first is J. J is having 1. So, I will do J here on machine 2. After that I have to D. Now, I am talking about this. So, after that I am having D, that is 4, 1 plus 4 5. So, that is D. After D I have to plan H. H is 5 9. Okay. So, this is how this is available. So, now after plotting these 3, now I can come to J again on machine 1. So, now J is available at 1. So, I can very easily do the J activity here, and J activity require 4 units of time here. So, 19 was here, 19 plus 4 23. So, my J activity is planned here. After that D requires 7, that is D, and after that I can plan H, which require 3 33 30, and this is how, then this is H. So, this is how I can schedule these activities on the Gantt chart also, and we can see that what is the how they are going. Now, once I have now come back to the machine 2 again, we have planned the 3 activities there. Next coming is E. E, let us see E. E require 5. So, 9 plus 5 14. So, let us write E here, and then after doing E, then do the G. G require 2, that is G, and after that L. L requires 8. So, we have to write 8, 14 plus 2 16, 14 16 8 24, somewhere up to here, that is my activity L. Now, I have to see that whether group machine 1 has released the job K or not, whether machine 1 has released the job K or not. K is already released at a point 0 1. So, I can take now K. Now, K time is 7. So, we can take 16 plus 8 24, and 24 plus 7 we can take 31. So, this is how I can go to now job K here, that is coming from the machine 1. After that I can take C. So, 31 here, 31 plus 5 36, I can take C, then I can take A, that is 3, 36 plus 9 39, that is A, and after that I can take I, that is 2 41. So, this is how 41 is the total make span time or producing all the 12 jobs on 2 machines. So, by the help of Gantt chart or with the help of a spreadsheet also, I can determine the total time required to process all the 12 jobs on 2 machines, and these 12 jobs are of 4 different categories, 4 different groups. So, friends, in these 3 exercises, first is Johnson's rule for n jobs and 2 machines, then we are having modified Johnson's rule n jobs and 3 machines, then we are having Jackson's rule, that is n jobs and 2 machines, but in different sequence. So, you have found that by applying the optimal sequence, we are able to reduce the make span time. Here this also as a exercise you can do that. If we are processing the jobs in the sequence A, B, C, D, E, F, G, H without the knowledge of Jackson rule, then what is going to be my make span time? Here it is coming to be 41 units. What is going to be the make span time if I follow the sequence A, B, C, D, E, F, and then you can calculate what is the improvement in the efficiency by applying the Jackson's rule by providing the optimal job sequence. Now, we are coming to a new case, that is we are using 2 jobs and n machines. Earlier it was a case of n jobs and 2 machines. Now, we are taking 2 jobs and n machines and we are applying the graphical method. Since it is a graphical method, so it has a limitation that we can use only 2 jobs. We can consider only 2 jobs because of the limitation of the graphical method. So, here 2 jobs are performed on n machines. Each job has different route in which it is to be processed on n machines. So, our job is to find out the route to be followed by these jobs, so that how to assign these jobs on on machines, so that the total make span time is minimum. So, each job has a different route, that is you will able to understand from this data, like job 1 has a machine sequence of A, B, C, D and E, whereas job 2 has a machine sequence C, B, D, E and B. So, 2 machines are having different job sequence and the timing requirements are also different on different operations, and in this given information, given condition, now we have to see that on machine 1 which job to be processed first, on machine A, machine B, machine C, whether job 1 to be processed first or job 2 be processed first, that we are going to find out. The algorithm will read like this. The procedure for doing this is like this, a very simple procedure. On a graph sheet, represent job 1 on x axis and job 2 on the y axis. Mark the timing of these 2 jobs on x axis and y axis, we will do that. Mark the processing times common to both the jobs on a machine by the shaded area, we will do that. Shaded area represent the simultaneous needs of a machine by both the jobs, and so we should not cross that. Then we will draw the 45-degree line, horizontal line and vertical lines starting from 0 0, left hand corner of the graph. This corner is 0 0 corner, the left corner of the graph 0 0 corner, on x axis 0, y axis 0, to reach the other side of the graph. We will try to draw the 45-degree line, where it is cutting we will go like this, horizontal line, and then again continue till we reach to the other corner, and we want to reach to the other corner as early as possible, so that the total make span time is minimum. Diagonal line represent when both the jobs are in progress. When we are diagonal line, jobs are in progress. If there is a vertical line, job 1 is waiting. If it is a horizontal line, job 2 is waiting. After plotting this, all the jobs which are coming above this 45 above the 45-degree line, they are to be processed in job 1 and then job 2, whereas the which are jobs which are on the other side of the line, they are to be first job 2 and then the job 1. So, this is how this procedure is. We will understand with the help of one example. We will understand this procedure of graphical method of sequencing 2 jobs on n machine with the help of one example. So, this is the example we are taking. We are having 2 jobs, job 1 and job 2. The sequence is also there and timings are also given to us. Machine sequence and timings are given to us, and then we have to determine the optimal sequence for these jobs on optimal sequence of the jobs on different machines. So, 2 jobs have to be performed on 5 machines. We will use the graphical method, and here as the procedure says, on x axis mark job 1, and on y axis we will mark the job 2. Okay. So, on a graphical method job 1 on the x axis, job 2 on the y axis, and then we can have a time scale. This is my 0 corner. So, this is 1, this is 2, this is just for the sake of convenience we can write these numbers like this. Similarly, on the y axis 2, 4, 6, 8, 10, 12, 14, 15 like this. So, we have made this matrix a graph sheet, and now let us mark the jobs on job 1. First is machine A. Machine A require, so that is the requirement of A from 0 to 1. Then it is going to machine B 1 to 3. So, this is machine B. Then 3 8 to 6 another 3, that is up to this, it is C. Then another 5, it is 11, 6 plus 5 11, that is D, and then it is going to E, that is 11 to 12, that is E. Okay. So, like this we have marked the machines for job 1, first A, then B, then C, then D, then E. Same way on the y axis we will mark the job 2. First is machine C for 3 units of time, this is 3 units of time, that is job C. Then A, another 4, 3 plus 4 7, that is A, and then we are going to D, that is 2. Then we are going to E, that is 1, and then we are going to B, that is. So, this is how I have marked the 2 jobs C, A, D, E, this is E. This is E here. So, C, A, D, E, D, E and B on this, and A, B, C, D, E on this. Now, we will match A on this side and A on this side, and this is my job A. This is my job A here. So, I can mark job A here. Similarly, B from this side and B from this side. So, this shaded area represent B. Then C on this side, C is 3 units. So, there is, so this also you can consider it as a shaded area. So, this is our C. This is our C, 3 units on this side and 3 units here. So, this is our C. So, consider this also as a area, and then D is 5 here, and D is here and here. So, this is our D area, and then E is this area. So, this is how we are able to define the area on our graph sheet, that this is the time when both the jobs are looking forward to machine A. This is the time when both the jobs are looking forward to machine C. This is the time when both the jobs are looking for machine B. This is the shaded area which represent that at this time both the jobs are requiring machine D, and this is a shaded area which shows that both the jobs are requiring machine E. Now, as the third step, if you see the graphical method which is given on a graph sheet, we have represented job 1 on x axis and job 2 on the y axis, and we have marked the timing also, and processing time on x axis and y axis, and based on this we have determined the shaded area also. So, up to step 3 we have done now. Now, step number 4, we have to draw the 45-degree line, horizontal line and vertical line without cutting the shaded area. Now, start from this corner, let us start the 45-degree line. We can take the help of these boxes, and we reaching here. Now, we are cutting the shaded area. I cannot cut the shaded area. So, I am having 2 choices here. One, I can take the horizontal path and clear the shaded area, and then again I can start the 45-degree line. and I can reach up to this place. Okay. Second option available with me here is I can from here I can take the vertical line, and after reaching here I can take the 45-degree line again. So, I am having two options available, option 1 and 2. You will find that by opting option 1, I am able to finish everything by time 15, 12 on this axis, and this I am able to complete it on by time 15. Okay. I am able to complete this job, the coordinate of this is 12 and 15. So, I am able to complete that, whereas the coordinate of this is 15 is here, maybe another 3 boxes. So, these coordinates are 18 and 15. So, I am finishing in 18 minutes, here I am finishing in 15 minutes. So, I will prefer this particular route. I will prefer this particular route. Able to divide these 5 machines into 2 categories. Certain jobs are certain machines are below this line. And on this side of the line. This is the line. This is the line which we are talking about. Okay. So, this is how we are the graphic to distribute the all the machines above this 45-degree line, others below this 45-degree. Decision how we are going to sequence the jobs, on the 2 machines. So, okay, consider this as also included in the sheet, and with the red color I have shown the path line. So, job A and machine A and B, they will process job 1 first and then job C, D and E, they will first do the job 2 and then they will do. So, we are able to define the sequence for of the jobs at different machines. On machine and then job 2, job 1, then whereas on machine C and D and E, job 2 and then job. This is how, and total time required to complete the job is make span time is 15. Okay. So, make span time is 15. We are able to complete the task in 15 by applying the graphical method of jobs on different machines. We were able to sequence the job on A and B, job 1, then job 2, on machine C, D and 2, then job 1. So, this is how we can perform the graphical. So, in the next session, we are going to take one is we will do the loading case, we will do the assignment model. By applying the assignment model, please see the assignment model from any overbook. Then we are also going to do another important type of case and one machine, but these jobs are with due dates, due dates. We are going to take up the 2 more cases here, that is assignment of workforce in a duty shift also. where you have to put the persons on a roster, off also, or 1 day off depending upon your policy, and then how to do the how to persons on different days of the week. So, that is going to take we are so, and then we will also talk about the issues which are associated. As we know, in service sector situation is slightly manufacturing sector, there we because in service system we have to take care that um, uh, uh, in the fastest possible manner, and we cannot keep the capacity in that case. There we have to keep additional workforce or ready in that case. We cannot store the jobs, cannot inventory the service system jobs. So, that part we will talk about in our next session. Close this session. Thank you.
Hello, psychology, and I work with the Department of Humanities and Social Sciences. Today I will talk about what is causal attribution or how of behavior. Causal attribution is one of the major topics in social cognition in psychology, and this refers to the fact that people attribute causes to their own behavior as well as to behaviors of others. So, understanding the antecedent conditions of behaviors and events is one of the major topics in social cognition. Causal attribution is about finding explanations, and these explanations serve a functional purpose, since they are useful in the purpose of planning of behavior and regulation of responses. As far as attribution of causes is concerned, generally people either do internal attribution or external attribution. Internal attribution, when causes are understood in terms of internal characteristics of people, and external attribution when causes are understood in terms of contextual and situational features. The main perspective that is employed in the understanding of causal attribution is the naive scientist perspective, and this has emerged from the research on attribution itself, and it views attribution process as a detailed and systematic causal search. And this is the dominant view about understanding attribution in social cognition. However, in recent time this is not the only view. There are alternative views also which try to understand how people make quick judgments about causality. So, now the question is that why is it that people make causal attributions? The answer to this question can be provided in terms of need for prediction and control. People need to predict their environment, and hence it is important for them to understand antecedent conditions of any behavior or any event. Also, causal analysis is related to various other processes other than attribution. It also becomes the basis of regulation of responses. People also develop causal theories based on their experience, and they employ these theories in different domains. As far as attribution theory is concerned, it consists of mainly three theoretical formulations. One is the Heeder's theory of naive psychology, the other one is Jones and Davis's correspondent inference theory, and the third one is Kelly's covariation model and causal schemas. There are other areas of psychology also from where some principles have been picked up and extended to understanding of causality. These areas are emotions, self-perception as well as personality. Psychologists have also tried to understand attribution in specific domain areas. Psychologists have tried to outline the different dimensions that people use to understand causality in domains such as achievement domain, that is understanding causality regarding achievement related behavior such as success and failure, depression, helping behavior as well as close relationships.